Assalamualaikum warahmatullah and good evening everyone. Are you able to hear my voice? Boleh dengar suara cikgu? Okay, alright. Bismillahirrahmanirrahim. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Alright, so tonight we discuss Pahang paper 3 section B. Last night we already finished discuss section A, the same paper. Alright. So I see now how many join. Okay, now we have 52 students. Okay, that's good. Alright, so we start now. Okay, I want to read the chat box first. Okay, ketua kelas dah ambil kehadiran. Okay, so we have student from SMK Meradong. Ada from SMK Batu Lintang memang ramai ya. Then Shaw, okay good. Lagi Sakura. Okay, any more? Selain daripada yang ada yang dah type? Semua dari Sarawak kah? I just want to see how far this live can go. Science 3? Science 3? What is Science 3? Sekolah apa Science 3? Unimap, okay. Alhamdulillah. Science 3 dekat mana? Oh, Science Miri. Okay. Science Miri, Selangor. Okay. Alia sekolah? From what school? Selangor? Okay, Matang Hilir. Alhamdulillah. Lagi? Ada lagi yang lain? Okay, section 16. Alright. Okay, so we start. Alright. So this is actually my 6th time, kali ke-6 live session. So if let's say you are new here, make sure you subscribe. Okay, subscribe this channel. Tak like pun tak apa. Okay, but make sure you click the notification bell so that when we have a live session or maybe when I upload any video, means that you can follow lah. Alright. So let's say we discuss question because I'm trying to have this live session every week. Okay, cikgu coba untuk tolong seramai mungkin student lah that taking physics. Alright, so since your year is a very special year where SPM is being postponed a few times, right? So I'm trying to help you all, okay, with the knowledge that I have, okay. Hopefully that this can tolong lah. I know your teacher in school very good already, okay. So cikgu just menambah sahaja, okay, what your teacher already teach, alright. Okay, so make sure you subscribe and then turn on the notification bell so that you get the notification, alright? And then another one is when we discuss any question, cikgu akan, you can click, okay? You can click on the description, okay? So you will get this. So cikgu akan letak link, okay? Where you can get the question, just like this question lah. Okay, boleh download soalan and you can try earlier. Okay, so when we discuss, then means that you already try. Macam like this kan, cikgu dah tulis lah. I already type here. Best if you can answer this question in 1 hour 30 minutes. Okay, so every time you want to do output learning, try to set your time. Okay, so just like this paper. So this is paper 3. It is 1 hour and 30 minutes paper. So maksudnya you set your time, okay, maybe you have your own macam dekat handphone kan ada timer kan, so you tekan 1 hour 30 minutes and you start. without referring to any reference book. Okay, as if you are really sitting for your SPM paper. Okay, get the feeling, so that when you sit for your real SPM paper, you will be calmer, lebih tenang. Okay, because you already practiced many times. Alright, so set your time 1 hour 30 minutes. Answer without referring to any book. Habis 1 jam 30 minit, then you can refer to your book. Okay, that is how you push yourself. Okay, that is actually one way so that you will be better, okay, in answering physics question lah. Alright, so we start. So cikgu terus buka soalan nombor 3. Kejap cikgu. Wait, I need to open the question first. Okay, question number 3, Pahang paper. Section A already discussed last night. You can look at last night live session. Alright. Okay. Okay, so this is question number 3 ya. Boleh nampak? Alright. Kejap. Any form 4 student here? Ada pelajar tingkatan 4 ke? Because this year, Form 4, they have different syllabus. Okay, where they have not learned this chapter. Okay, this question. Ada tingkatan 4 kah? Any Form 4 student? If got Form 4 student, cikgu nak bincang question number 5 first because they already learn with. If no Form 4 student, so cikgu terus pergi number 3 lah. No, tak ada Form 4 student lah. Okay, alright. So we look at this question lah, question number 3 ya. Alright, so diagram 3.1. Okay, 3.1. So you need to read the question carefully. Okay, so diagram 3.1. 3.1 shows diver is diving in a swimming pool. So diagram 3.2 shows diver is diving into the seabed. Maksudnya ada dua. One is seabed, the other one is swimming pool. And then they are at the same depth, but the diver in diagram 3.2 feel that his ear is sick. So diagram 3.2. So it means at the seabed. Huh? Nampak kan? Sea water actually. Alright, so ada logik ke? Swimming pool sama dalam dengan sea water. Okay, tak apalah, boleh terima lah. Alright, so first you need to look at these two diagrams carefully. Okay, so observe the diagram carefully. Try to come out with two variable. Okay, two variable from these two diagram. Okay, what are the variable that you can see, that you can observe? Okay, so already mentioned in the question. So this is swimming pool. Okay, swimming pool. This is sea water. And they are at the same depth. Kedalaman sama, kedalaman sama. And then diagram 3.2 sakit telinga. Diagram 3.1 telinga tak sakit. Okay. So what are the two variable involved? Okay. Alright. So since this is swimming pool, so we know this is fresh water. Okay. And then this is salt water. Okay. Masin, right? So it means that the variable involved here is actually density. Alright. So density of the liquid. Okay. Then alright, then okay, so this is the density of the liquid. Then after that, actually cikgu baca your chat box. Cikgu tak faham that one. Scam form 4. What is scam form 4? Kadang-kadang cikgu tak faham istilah you all, you know. When you write scam form 4, I don't understand that. No legit. What do you mean by scam form 4? Okay, tak apa. We continue. Alright. So the variable involved is density of the liquid. Okay, the other one is pressure. Okay, but you have learned that pressure, there are a few pressure. One is the normal pressure, which is equal to F over A. Alright, satu is F bahagi dengan A. That is the normal pressure, right? Another one is atmospheric pressure. And then another one is pressure in liquid. Okay, so here water, right? So we can say pressure in liquid. So P equals to H rho G. Okay, now further reading, baca terus. So as usual, you will be asked to write your inference, your hypothesis. After that, okay, you are given a few apparatus, just like this. They give you teaser funnel and tall beaker. Okay, so you have teaser funnel, you have tall beaker. Alright, so you need to describe experiment framework to investigate your hypothesis. So make sure your hypothesis can be tested in physics lab. Okay, so in your answer, okay, so you need to have your aim. Okay, your aim 1 mark, variable will be 2 marks. Okay, and then list of apparatus material is 1 mark. And then arrangement of apparatus 1 mark, procedure will be 3 marks, 1, 2, 3, and then the way you tabulate your data will be 1 mark. Okay, this is 1 mark, and then the way you analyze data will be 1 mark. Okay, so all together will be 10 marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now so let's say after you look at this diagram, you still don't know what is the variable or maybe what experiment, okay, is this problem diagram about. So you can look at the apparatus that they give. So this also can give you idea. Alright, so here memang it will be pressure in liquid. Okay, so your manipulated variable is density. Okay, betul. Theo jamming, betul. Density. And then your responding variable is pressure. So to be more specific, it is pressure in liquid. Okay, boleh faham? Alright, so what will be the inference? Ada siapa-siapa nak jawab? Tulis. Type in the chat box. Okay, what is the inference? Anybody? It's okay. Okay, so if possible, try to type if contoh macam kadang-kadang cikgu tak faham what you type, so I will ask. Okay, ada lagi jawapan lain? Theo, pressure of liquid depends on its density, and then Zat, the pressure of liquid depend on the density of the liquid. Von, pressure in liquid depends on the density of the liquid. Jasmine, oh semua sama. You all copy paste kah? Okay, semua sama, semua betul. Alright, so I see most of all of you using the word depends. Semua betul. Alright, yeah, that is correct. So pressure in liquid depends on the density of the liquid. Okay, ataupun you can also write pressure in liquid is affected by the density of the liquid. Okay, faham? Ataupun density of liquid affects pressure in liquid. Okay, so ada a few way to write. Okay, so easy will be you just memorize one. Since you all love the word depends, just use it like that. Betul. Aiza pun betul. Very good. Okay, next one. Hypothesis. Kejap. Can you write like this or not? Satu okay, kan dekat here you see sick. Okay, so if let's say a student write the inference as apa nak kata, let's say in BM, kesakitan telinga penyelam bergantung kepada ketumpatan cecair. Can or not? For inference. Bolehkah tulis kesakitan telinga bergantung kepada ketumpatan cecair? Okay. Vincent said no. Amza very confident. Definitely can. Probably can. Boleh. Inference, yes. As long as you have two variable, okay, alright, and then it is not very clear, the relationship is not clear, means that you are using the word depends, okay. So here you can write about the painful in uh, the diver ear, that one can, okay. Tapi I will suggest you to just straight using the variable that can be used for your hypothesis. So it means that your previous answer, yang jawapan dekat atas tadi, that one is the correct one. Okay, that one memang apa, marker will not have to stop for a while thinking whether to give you mark or not. Okay, clear? Okay, type the hypothesis. Wait, laju. Okay, seawater's pressure is greater than seawater's pressure. The greater the depth, the greater the pressure in liquid. Okay, lagi. Okay, very good, Bradley. Tunggu lagi yang lain. Semakin bertambah ketumpatan, semakin bertambah tekanan. Okay, I'm waiting for some more. Okay, good, Trinity. The greater the density of liquid, the greater the pressure in liquid. Wah, banyaknya. Tunggu ha, cikgu perlu baca. Okay, Vincent. Alright, now cikgu baca. Okay, cikgu baca first ha. Wah, laju. I need to speed reading. So, the answer, kejap Chai Chang Hong. The greater the density of liquid, the greater the pressure in liquid. That is the perfect answer. Okay, so maksudnya jawapan Chai Chang Hong, jawapan Jennifer, pressure in liquid increases as density increases. Correct. And then Aiza, the density of liquid increases, pressure in liquid increases. Yes, correct. Tepat. Horizon, the higher the density of liquid, the higher the pressure in liquid. Yes, correct. And then, tunggu cikgu baca yang bawah. Tan Shirui. So, the pressure in liquid increases with the density of liquid. Yes, betul-betul. Okay, kebanyakan tepat setakat yang cikgu baca from Bradley. Trinity betul, semakin bertambah ketumpatan semakin bertambah. Trinity, tambah sikit your answer. So semakin bertambah ketumpatan, semakin bertambah tekanan dalam cecair, because this is focusing on pressure in liquid. Okay, right? It's better to write tekanan di dalam cecair. Okay, Amza. Okay, focus on Amza quick answer. Seawater's pressure is greater than seawater's pressure. Amza, betul kah? Seawater and seawater, is it? If like that, memang, if you write seawater's pressure is greater than seawater's pressure, that one tak betul. Okay, because here we know that there are two variables involved. So we have the density of the liquid and pressure in liquid. Okay, so density and pressure. So it should be the greater the density, the greater the pressure in liquid. Number 2, apa maksudnya? Seawater greater than fresh water. Okay, seawater greater than in term of pressure. Can you write the complete answer? Your complete answer, Amza? Ashraf, meaning that we have to be very specific in our answer by putting, yes, yeah, that would be best. Okay, pressure in liquid. I'm trying to teach you all the safe way to answer this paper. Maksudnya, when marker read your answer, they don't have to think too long to give you the marks. Maksudnya by reading, they say, oh boleh bagi markah terus. Okay, terus boleh bagi markah. Okay, definitely correct like that lah. Huh? Okay, cikgu baca jawapan Hamzah. So the pressure of seawater is greater than fresh water. The pressure of seawater. Now we are talking about hypothesis. So when we write hypothesis, make sure your hypothesis can be tested in physics lab. Okay. So normally we use the word the greater this, the greater that. Ataupun the greater this, the smaller that. Okay. Now, okay, cikgu baca jawapan Hamzah lagi. So the pressure of seawater is greater than fresh water. I look at that answer as pressure and type of water. Okay. Alright. Cikgu masih baca jawapan Hamzah. Pressure of seawater is greater than fresh water. So when you write like that, I can see the variable is pressure. The other one is type of water. Okay, not the density of water. Okay, so it need to be specific what physical quantity that you use. Okay, clear? Alright. Okay, so they give you tisophenol, they give you tall beaker. So when you write your answer, make sure tulis soalan just like this. You make sure you write A, B, okay, A inference you write, and then B hypothesis tuliskan. And then make sure you write correct numbering just like this. C1 M. Okay, so it is the M. So M will be since okay, this is why your hypothesis is very important. Okay, because your aim, your variable, okay, your procedure, your table, and your graph will be using the same two variable. Okay, so take time to write your hypothesis. Ambil masa, okay, fikirkan. Okay, ingat ayatnya. Contohkan your hypothesis should be the greater this, the greater that. Okay, so while waiting for you to generate your answer, you can tulis lah the greater blank, comma, then tambah. Okay, and then just like this also, for your aim, you can write to investigate the relationship between, you can put blank first because you need to generate your idea. While waiting kan, to save your time, boleh tulis sikit-sikit lah. Okay, just like this one, variable, manipulated, responding, constant. Okay, later you fill in. Alright. So I have jawapan pelajar. I have a few here. Kejap. Okay, so I have a few students answer. Okay, we look at this. Okay. I have not checked. Cikgu belum check. Ada banyak yang hantar dekat cikgu. Come, we check together. Boleh bagi markah ke tak? Alright, so inference just now, water pressure depended on density of water. Water pressure depended on density of water. Okay, boleh terima? Can or not? Water pressure. Okay, boleh lah, can accept. Tapi kan cikgu ambil masa fikir kan? Okay, because water. Okay, pressure in liquid depended on the density of liquid. Liquid is better lah, okay, because water will have a constant density. Kan? See, the higher the density of water, again, it's better to use liquid. The higher the pressure in liquid. Okay, pressure in the liquid. Water pressure. Water pressure. Pressure in liquid. Okay, and then to investigate the relationship between density of another one, liquid. Okay, better to use liquid. And then here, density also liquid. Okay, kejap cikgu pergi cari jawapan lain first. Later we look at this answer again and we discuss. Okay, look at this. So inference boleh terima density of liquid, the density of liquid okay, so density of the liquid affects pressure in liquid, betul? Okay, if you use the word affects, you can write like this. If you use affected by, pressure need to be in front lah. Okay, so this is correct. Okay, 1 mark. And then the greater the density of the liquid, the greater the pressure in liquid. Okay, perfect. And then investigate relationship between, just use the two variable just now kan. Here, density of liquid, pressure in liquid. Okay, so investigate relationship between density of liquid, pressure in liquid. Betul. Okay. And here, now, so your variable, manipulated variable, density of liquid, okay, good to write symbol, this is correct. And then pressure in liquid, also good to write symbol. Make sure your symbol have a difference. Mesti nampak perbezaan. This one, be careful lah. Okay, since you use, make sure nampak your P and your rho, make sure nampak. So these two, manipulated responding, this is tip 1. Okay, and then this one, alright, better to write manipulated variable, responding variable. Okay, unless you really don't have time. Okay, then you can write like this. Okay, then depth of liquid will be the constant variable. Betul kah? Is this correct? Constant variable. Ada lagi yang lain kah instead of depth of liquid? Okay, this is correct kan? But do we have other answer selain daripada this? Now, how do you determine the constant variable? Okay, Adila, volume of liquid. Boleh kah? Gravitational acceleration, zat. Okay, ada lagi? Now, how do you determine the constant variable? How to get confirm correct constant variable? Any idea? Selalunya, physics experiment, it relate to a formula. Okay, good Ashraf, yes. So, actually, when scientists, okay, when scientists last time lah, okay, this siapa-siapa physicists when they look at problem, they think of an inference, then they come up with hypothesis, then they do experiment. From the experiment, they tabulate data in table and then plot the graph. So from the graph, they come up with a formula. Okay, when they write conclusion kan, they write a formula. Okay, so it means that if you can relate the experiment to formula just like this kan. So this is pressure in liquid. So the formula is P equal H rho G. Okay. So now you know that the density here is the manipulated variable. And then the pressure in liquid is the responding variable. So it means that we have two constant variable, which is H and also G. Alright, so since G memang, okay, normally we write H lah, okay, H. So depth of liquid 1 is enough because this is 1 mark. If you write G, make sure you write this correctly. Okay, maksud cikgu, make sure you write gravitational acceleration ataupun gravitational field strength. Okay, so what about volume? Can give mark or not for volume? Since here there is no volume kan, so we don't accept volume. Okay, clear or not? Because we look at the depth, no matter how much is the volume, but we will look at the depth. Katakan let's say like this, right? So we have beaker like this, and we have another beaker like that. Katakan so volume like that. Okay, so but we actually focusing on the depth only. Okay, not the volume. Clear? All right. Okay, next, apparatus material. So apparatus material and also the arrangement of the apparatus. So make sure after you draw, make sure all the one that you draw must be list up. Okay, especially the instrument that you use. Okay, now check. Any comment? Okay, I let you comment. Look at the answer. Ataupun maybe look at the apparatus arrangement first. Cikgu besarkan diagram. Yeah, yes, Amza, you need to memorize the apparatus. Okay, sebab kalau you don't memorize the apparatus, then quite hard for you to write the procedure, the diagram kan, mesti ingat. Okay, so diagram betul kah? Any comment? We look at the diagram first. You can comment the diagram. Need to label the water in manometer as colored water. Good. Okay, did not label the liquid. Okay, lagi, some more. Alright. Ada lagi? Retort stand. Okay. Good question. Tak apa, tulis. Okay, so the apparatus arrangement, okay, must be function apparatus diagram. So it means that if let's say we set up the experiment based on your diagram, we are able to get our responding variable. Okay, if you can get the responding variable by setting up the apparatus, then your diagram can be given 1 mark. Scale on the beaker. Okay, lagi sama. Macam cari harta karun, right? Show the manometer reading. Okay. Draw arrow. Okay, dah? Alright, now. Okay, so rubber sheet kat hujung teaser funnel. Kan? Okay, now. Sebenarnya my student sengaja lukis like this, okay, so that it give opportunity for you all to add in, to comment, okay. Yeah, rubber tube need to be held by the retort stand. Okay, come on, we start. So this experiment, sekejap. Alright, so number 1 memang you need to label. Okay, so there must be, this must be labeled also. So this is actually, you can write cellophane, you can write rubber sheet, okay, this part. Teaser funnel, label, rubber tube, okay, make sure your label kena lah, don't like that, okay, make sure kena, like that. Okay, tall beaker, here is not clear. This is not clear. Is this the line here? Okay, tak clear. So it's better for you to shade it ataupun macam loretkan sikit ke, ataupun okay, can do like this lah. Can loretkan sikit. Okay, ataupun buat titik-titik ke here. So and this must be label. Okay, so need to label water in manometer. Yes, you need to label this. It can be coloured water, boleh diterima. It can be paraffin oil. Okay, selalunya that lah. Coloured water ataupun paraffin oil. Biasanya we use coloured water. Okay. Alright. Betul lah jawapan soalan Theo just now. Okay, mesti label. Label the liquid. Okay, yes. Liquid pun perlu label. Can write here liquid. Okay. Retort stand is not compulsory. Okay, sebab you can hold this by using hand pun. But if you use retort stand, it will be more accurate. But without retort stand, if you ask your friend to hold this, okay, still you can get your responding variable. Maksudnya retort stand tak wajib. Okay. Ruler wajib. Okay, ruler wajib. Manometer, alright. Then, alright, so this must be label also. Okay, maksudnya, you see this is the level of coloured water kan? So, because you want to get the pressure which is represented by the difference in the liquid level of the manometer kan, so you need to have this. You put dotted line, okay, and then you do this. Arrow like that, right? Then you put H. It depends on what you use to label this. Can be H, can be L. Katakan L lah, because this one will be H letter. Kedalaman here, this one we use normally H lah, kedalaman. Depth, okay. And then this one can use L, okay, difference in the liquid level of the manometer. Can use mercury. Mercury is carcinogen, so tidak digalakkan. But if you use mercury, still can get the reading. Okay, it means that your diagram is function, but better not lah. Okay, we don't use mercury in physics lab also. So the only mercury that we have in physics lab is the one that in your liquid thermometer. Okay, ada lagi? Yang lain cikgu rasa no problem. Okay. Here kan, pressure in liquid. So in this case, pressure in liquid, we don't have instrument to measure pressure in liquid. So that's why you need to write is represented by a manometer reading boleh. Okay, manometer reading. You can also write a difference in the level of liquid in manometer. That one lebih tepat if you write difference in the level of the liquid in manometer. Okay. Boleh. Need to label depth of liquid better. Okay. Walaupun H is not your manipulated variable, this is a constant variable kan up here. Depth of the liquid, comma H. Just label it. Okay. Boleh ha? Cikgu jawab semua dah kan? Okay. Scale on the beaker is not compulsory. Okay, now. Okay, fill up beaker with water. Lower the end of rubber tube with tissue funnel attached into water with a depth of 5 cm. Okay, that one no marks. So this is a constant variable, but you better write it. Measure the manometer reading. Repeat the experiment with seawater and alcohol. So how? So here you see the table. Density of liquid, rho, kgm, -3, manometer reading. Seawater, alcohol. Manometer reading, density of liquid. Any comment? Okay, kejap. Now is already 10:15. Cikgu takut jadi macam last night. Cikgu ajar sangat perlahan. Okay, I pick. Kejap. Cikgu ada jawapan pelajar that can be given most of the mark. Okay, I open that one first. Okay, I show you that one first. Tunggu sekejap. Sekejap. Cikgu cari jawapan sebab ada banyak. There are a lot of answers. Tunggu. I need to open the PDF file one by one. Okay, I think this one. You know whose handwriting is this? Those who come last night, you know whose handwriting is this? Okay, so this is Vincent answer. Alright, so see, the first one dah betul dah, ha? Okay, so this one okay. Alright, so pressure in liquid depends on the density of the liquid, and then the greater the density of liquid, the greater the pressure in liquid. Okay, to investigate the relationship between density of liquid and pressure in liquid. So this one, the sequence, you can change the other way around also no problem. Maksudnya between pressure in liquid and density of liquid pun boleh. Okay, this one tak ikut susunan lah. And then the variable, okay, so density of the liquid, pressure in liquid. Okay, good to put symbol behind like this. Okay, so this is manipulated responding is 1 mark. And then the constant variable, better to put H. Okay, so this is another mark, satu markah. Okay. Okay, then since pressure in liquid, we don't have instrument to measure the pressure in liquid here. Okay, so we need to represent it by like this lah, represent by the manometer reading. Good. Oh, you use H. So here, since you use H here, so depth we can use L. Make sure jangan sama. Okay, jangan sama lah this symbol. So if you use H here, so here this one may be L, like that. Okay, so the apparatus material. Okay, this one diagram lengkap ah. Cikgu besarkan. Ada yang missing ke in the diagram? So the liquid inside here, Vincent, better to you can loretkan lah. You can shape it. Okay, ataupun buat show this is liquid, and then label. So label this as coloured liquid. Mesti label lah. Just like this, katakan you don't label. So here, this one boleh tidak diberi markah, this diagram. Although this diagram is already perfect diagram. Okay, mesti di label. Alright here. And then also label this part. Okay, label rubber sheet. Okay, or cellophane. Okay, ada lagi ke? Okay, H memang nampak beza lah. Okay, this and this height, that is H. So the difference in the liquid level. Selalunya we use L. H normally we use for the depth of the liquid. This one label. Okay, I prefer student to use H for the depth and then here L. Okay, tapi I don't say this is wrong lah. Still can accept. Okay, ada lagi yang kurang? Ruler ada. Okay, so if you, this one mesti di label. If let's say the marking is strict, so the whole diagram will not be given mark due to this, the coloured liquid level. Mesti di label. Okay, jelas ah? Look at the apparatus that Vincent already label. Nampak semua? Is it jelas? Cuba kecilkan. Okay, semua ada ke? So when I look at the apparatus material, I will search for the instrument first. Where is the instrument? Means that I want to see the meter rule first. Where is the meter rule? Ada. So after I see the meter rule, then I will look at the rest. Diaphanal, tall beaker, measuring cylinder. Measuring cylinder. Measuring cylinder, rubber tube, rubber band, rubber sheet, manometer, retort stand with clamp, liquid with density, ... Okay, now look at the question. Where is the tall beaker? Where's the answer just now? Where's the tall beaker? Tall beaker is not here. Here ada. But here, do you have tall beaker? Oh, ada. I see, you have two. Okay. Alright, no problem. Semua betul. Okay. And then good here, Vincent already write the density of the liquid that he used. Okay, so from 500 kg per cubic meter, okay, 1000, 1500, 2000, 2500 kg per cubic meter. So you have 5 reading, 1, 2, 3, 4, 5, good. Okay. Ataupun here you write liquid with different density. Boleh. Then make sure in your procedure you write the 5 reading. Okay, so means that this is already 1 mark. Betul-betul. Okay, look at the procedure. Set up the apparatus as shown in diagram above. Pour 500 Tan Shiroi, do we need to separate? For physics, no. For physics, you don't have to separate apparatus and material. Boleh campur. For other subject, tak sama Okay, you don't use physics method to answer your chemistry. Jangan follow your chemistry teacher. Okay, if it need to be separated, so make sure you separate it. For physics, so far, more than 10 years already, cikgu nampak they don't strict on that. Boleh campur. Okay. Oh, alright. So pour 500 cubic centimeter of liquid with density, baguslah. Density 500 kg per cubic meter into a tall beaker. So this is the first mark. So this is your first manipulated variable value. Okay, ataupun you can write the experiment is started using liquid with density 500 kg per cubic meter. Pun dah dapat satu markah. Your first reading. Okay, your first reading. Then, lower the end of the rubber tube with is a funnel attached into the liquid the depth of 5 cm. This one tak ada markah, but need to be stated. Okay. Alright, next. Measure and record the manometer reading H using a meter rule. Okay, measure and record manometer reading H using a meter rule. Okay, correct. So these are the keyword mesti ada. Measure manometer reading H using meter rule and recorded. Okay, so maksudnya ada dua this one. Measure and record. These two pairing mesti ada ditulis. Okay. Alright, like that. And then repeat experiment using another 4 more reading. 1, 2, 3, 4. So this is tick number 3. This one just now is tick number 2. Okay. Now, this tick number 2 only can be given if up here you already write. Okay, pressure in liquid is represented by the manometer reading. Katakan you did not write this. Tiba-tiba dekat bawah record measure manometer reading and using meter rule and record. So if you just write like this without relate this to your pressure in liquid, so this will not be given mark. Jelas Okay, because macam tiba-tiba hanging your story, because here you write the responding variable is pressure in liquid. Tiba-tiba dekat bawah get the reading of the manometer. So make sure you write this represented by manometer reading. Clear? Okay. Next one. Alright, your table. Biasalah, I told you already before, you must write 3 things. Name, symbol, unit. Here also the same thing. Name, symbol, unit. So this can be given mark because why? Just now you already mentioned the manometer reading is the represented the pressure in liquid. So mesti this one sangat-sangat penting. Okay, if you don't want to write here, make sure in your procedure kena tulis just like this side, right? Measure and record. Measure the manometer reading H using meter rule and record. Then next sentence will be the manometer reading represent pressure in liquid. Then only can give this mark. This mark also. Okay? Your responding variable should be on the vertical axis. Okay, your horizontal axis will be the manipulated variable. Okay, kejap. Cikgu baca your soalan lah. Bang Bom Tata. Susahnya sebut your name. Teacher, for manipulated variable, can I write pressure of liquid represented by mass? Pressure in liquid represented by mass of salt dissolved in water. I think you want to write density, is it? Kalau density, yes. Okay. So if you write density of liquid represented by the mass of salt dissolved in water, boleh. Can. So it means that later I show you. Ada student jawab like that. Okay. Hamzah, manometer reading don't have to provide. Oh, inside here ke? This one biar kosong because this is planning. Okay, planning experiment. So we can only write the manipulated variable value. Okay, so this one biar kosong. Even your graph pun tak ada, you don't draw line inside because this is planning. So means that when you before you do your experiment, you already plan. This is how I should tabulate my data. Maksudnya when you come to physics lab, you just need to do the experiment and then masukkan nilai. Okay? And then the graph, you know already which one should be on the vertical axis, which one is the horizontal axis. So just biar kosong. And this is good. Sentiasa letak 0. Okay? Alright. So we search for the one that using density salt. Tunggu sekejap. Ada student that using salt. Here. Okay. So yang lain semua betul lah, sama. Okay, only here different. Manipulated variable, density of liquid represented by mass of salt added. Boleh. Correct. Water pressure. Oh, just now, this one is the water pressure. Should be pressure in liquid. So that's why I say, when you write your answer, make sure the variable that you use from the beginning mesti sama. Jangan tukar-tukar. Okay, like this one dah betul dah. Liquid pressure in liquid. We use pressure in liquid. Density of liquid. Okay, density of liquid. Pressure in liquid. Kan? And then tiba-tiba here jadi water. Use liquid pressure. Pressure in liquid. So here betul lah. Can accept. Okay, density of liquid represented by mass of salt added. So this one boleh diterima. Can. Okay, the first mark. And then depth of isophonal immersed in water. Alright, boleh. Liquid lah, liquid. Now we look at the procedure. This one good. Kejap. Apa yang kurang? Mercury. Distilled water, tall beaker. H is not label. Okay, H perlu label and then hujung pun perlu label. Okay, so this one need to label. Cellophane or rubber sheet. And then macam tadi lah just now. And then here make sure you underline it. Draw a line. Like that. Okay, to show that is your H. Mercury, better to change it to colored liquid. Okay, colored liquid. So this is carcinogen. We don't use it in physics lab anymore. We don't have mercury already. Okay, except for the one that you have in your thermometer. Meter rule, yes. Yeah, meter rule mesti ada. Okay, Millie can hear my voice? Alright, so we look at the answer here. Since this one is using salt, come, we read together. The first mark can give or not? Tall beaker filled with distilled water, 10 grams of salt added into it. So tesophenol connected to the manometer using rubber tube. So apparatus is set up as shown in the diagram above. So teaser funnel is lowered and fixed to a depth 10 cm. So difference between two arms of the manometer head is measured using meter rule and recorded. Then experiment repeated by adding different amount of salt into the tall beaker, 20 gram, 30 gram, 40 gram, 50 gram. Okay, any comment? Mark number 1 can give? Mark number 1 can give or not? First manipulated variable value. Kejap. Are you able to see my screen or not? Yes, okay, good. Cikgu takut the screen is not there. Alright. Vincent, teacher need to fix the volume of distilled water. Yeah, yes, okay. In this case, yes, because you are adding salt into the water, kan? So means that the volume of the water should be constant. Kejap, let me see. Didn't mention the volume of water. Yeah, okay, yeah, that is one of the weakness. Okay, so the volume of the water need to be mentioned since you are adding salt into the water. So the volume must be fixed. Okay, ada lagi? Okay, so it means, can we give the first mark or not? Tall beaker filled with distilled water. 10 grams salt added into it. Yeah, first you need to write. So the tall beaker is filled with, okay, let's say, you can write 1 liter, you can write 500 ml pun boleh. Okay, 500 ml of distilled water. Then you can write salt. Cikgu suka student write like this. Salt with the mass of, okay, ataupun salt with the mass M. Okay, salt with the mass, okay, comma M equal 10 gram. Cikgu suka student tulis like this. In this case, you don't write decimal place pun tak apa. Okay, because this is just planning. Right? So, right, salt with the mass M equal 10 gram is added into the water. That will be clearer. So, means that this is your first mark. Okay, your first manipulated variable value, because up there already written, right, the mass of water, the mass of the salt added represent the density. So, means that this is the density lah. Okay, next. Teaser funnel connected to the manometer using rubber tube. Okay, teaser funnel lowered to a fixed depth of 10 cm. This one no mark but need to be mentioned. So the difference between two arms of manometer is measured using meter rule and recorded. This one betul. Okay, this is mark number 2. And then repeated. Okay, this is mark number 3. Okay, but look at the symbol, H. Betul kah H? Betul. Okay, so make sure the symbol that you have here sama. Alright. Okay. Then okay. So mass salt added, difference in height of, okay, sama lah. So this is 1 mark, and then your graph 1 mark. Better to tambahkan lah here M, mass, comma M. Okay, so far ada soalan lain? Okay. Ada soalan lain? You see, this student using P pun boleh, but okay, that's why I said this line is important. Make sure you draw the line. Lukiskan this. Otherwise macam P tiba-tiba like that mah. Mesti tunjuk line. Okay. Let me see. Sama, ramai tak label the cellophane. Wait, just now I see one interesting answer. This one pun sama, label P. Sekejap. This one in BM later we see. There is one answer just now that is interesting. Sekejap, cikgu baca direct. This one okay. This one pun okay. Look at this. Okay, so density of liquid represented by the different type of liquid that have different density. Like this can or not? Like this pun boleh. Okay, liquid A, B, C, D, E means that there are 6 liquid with different density and the value of the density is given. Like this also can. The unit, make sure unit betul Okay, jangan tiba-tiba unit jadi Newton, density become Newton. Jangan. So the unit must be kg per cubic meter. And then here, I think okay. Alright, now look at this. Any comment? And look at this. I'm interested with this term. Okay. And then look at this term. Okay, so any comment? Can we use the word increase or not? Increase of height of colored liquid level in right arm of the manometer. In right arm. Cikgu besarkan. Increase. This student using the word increase. Diagram already nice diagram kan? So can we use the word increase in the level of the liquid in the right arm of the manometer? Bolehkah? Actually yes, but no. If increase, kejap If you write increase, maksudnya like this. That's why I say the term is very important. Salah perkataan that you use, okay? So the meaning lari already. Okay? Let's say so maybe first time you use it is like this. Second time maybe, okay, katakan the first time is like this. That is the colored liquid kan? Maybe until here. Okay, so the difference in liquid level will be this level. This is your H. Katakan H. Then second time you do the experiment, still using, tak apa I'm using color like that. Second time you do the experiment, maybe this is lower, bawah. And then this one makin tinggi. So are you able to write increase in the liquid level on the right arm, where we don't measure from the same point, we measure it from here, like that. So that is why if you write increase in the liquid level, it will be already wrong. It should be the difference, perbezaan ketinggian. Okay, clear? If we darken the liquid in manometer, will it counted as solid as liquid? Should be labelled in dotted line. Yeah, it's better you use dotted line. Very good, Natio. Yeah, betul-betul. It's good to label it with dotted line. Okay. And make sure you label, tuliskan coloured liquid. So if you darken it and you write coloured liquid, so we know it is liquid. Okay. Okay, jelas? Okay, so we can move on to question number 4. So cikgu boleh tutup this one. Okay, look at number 4. Kejap, BM1. Okay, I want to show this. Okay, because this is sent by sekolah lain, pelajar sekolah lain. This is not from BL student, bukan from Batu Lintang. Okay, we look at the answer. And it is in BM. Okay, so kita tengok betul tak? Alright, so I think the first A and B she forgot to send me. Terus pergi C, tak apa. So tujuannya menyiasat hubungan antara ketumpatan dengan tekanan. Can or not? Perlu tambah apa-apa? Okay. Menyiasat hubungan di antara ketumpatan dengan tekanan. Perlu tambahkan ketumpatan cecair dengan tekanan di dalam cecair. Perlu tambah, And then dimanipulasi ketumpatan, right, ketumpatan cecair, and then tulis simbol. Okay, make it a habit to write the symbol. Okay, then beza ketinggian paras air di dalam manometer Y. Okay, kejap. Can or not? Can we write like this? Bergerak balas. So bergerak balas sepatutnya tekanan di dalam cecair. Means that you need to use this. Gunakan this one. Tekanan di dalam cecair. Then this one, beza ketinggian paras air dalam manometer, mewakili, diwakili. Okay, so tulis here tekanan dalam cecair, then buat kurungan, diwakili oleh perbezaan ketinggian paras air dalam manometer, and then dimalakan kedalaman air. Okay, betul. Bukan kedalaman air, sebenarnya kedalaman. Okay, tak perlu tulis kedalaman air. Kedalaman, because it depends on where you until where you immerse your teaser funnel. Okay, so radas ada yang kurang? Okay, maybe we look at the radas. This is the diagram. Okay, comment. If you are able to see what is missing in this diagram, so means that you know already how to draw correct diagram. Apa yang kurang? What is missing? Yes, good. Water in the beaker. It looks like the teaser funnel macam terapung di udara. Okay, that's why you need to label. And then use dotted line lah to show water. Mesti label lah. Diagram dah cantik, sayang lah. Mesti label. Sayang, if let's say you do like this, maksudnya tak ada markah untuk diagram. So in your exam, try to draw the diagram as fast as possible. Don't spend too much time, because this is only 1 mark. Okay, 1 markah. Lukis dengan laju. If you have time, then you spend you can redraw your diagram like that lah. Safe will be mungkin you draw first dengan laju, then you leave a few row, okay, then if you have time then you can redraw the diagram, okay. After katakan you finish your new diagram, then the first diagram you just cancel kalau katakan sempat lah. Alright, so this one make sure label and then buat dot 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 lah. So this is liquid, and then here air berwarna, manometer. Ada lagi kesalahan? Oh, label. So this one tunjukkan this is your L ataupun H lah, depends on what symbol you use. Okay. Corong tisa, bika tinggi, air, tiup getah, manometer, penimbang elektronik, kaki retot, pembaris. Cellophane, apa lagi? Penimbang elektronik. See what is the use of this penimbang elektronik? Okay, because using garam. Bika tinggi dipenuhkan dengan air, isi padu 200 ml. Actually 200 ml is quite little, agak sedikit. You imagine your mineral water, yang botol kecil, how much? Berapa liter? And then botol besar 1 liter kan? 1.5 liter, right? So botol kecil is around 500, I think. Sikit. So this one you can write 500. Okay. I don't say this is wrong. Boleh terima. Campur garam berjisim. So here ketumpatan lah. Kejap, we check first. So garam berjisim 15 gram. Rendam dalam keadaan menegak. Pembaris meter eksperimen diulangi dengan jisim garam. And then here jisim garam, beza ketinggian. And then, the graph tak ada. Now, so you see when you read this answer, nampak kan you put a question mark. What is jisim garam to do with this tujuan? Tujuan kita mengkaji hubungan antara ketumpatan cecair dengan tekanan cecair. Dimanipulasi is ketumpatan cecair. Bergerak balas, tekanan cecair. And then dimalarkan kedalaman. Now here, okay, cikgu tak nampak pun perkataan ketumpatan cecair. Cikgu pun tak nampak perkataan tekanan cecair. So, macam hanging. Do you see or not? Okay. Alright. Are you able to see kelemahannya? So that is why when you write your answer, you follow your hypothesis. Hypothesis dah ada two variable. So your M will be the two variable also. So your manipulated responding also that two variable. In your procedure, make sure you have that two variable. Okay, otherwise macam hanging kan, ceritanya macam tergantung. So this is the hero and heroine katakan. And then dalam cerita tak nampak pun where is the hero. Ketumpatan tak nampak. And then the tekanan also not here. Okay Boleh Alright. So this one cara jawab is the same as the one that adding salt just now. Alright. So mesti tulis ketumpatan. It's either you write here ataupun tulis kat bawah. Jisim garam mewakili ketumpatan cecair. Then only ada kaitan. Maksudnya if you already write in your procedure ataupun tulis dekat atas ketumpatan diwakili oleh jisim garam, so here dapat bagi markah. And then here this one pun mesti dinyatakan awal lah. Maksudnya here mesti tulis tekanan dalam cecair diwakili oleh beza ketinggian paras air dalam manometer. Okay? Faham? Okay. Okay, so continue number 4. Okay, but good. Okay, so bagi cikgu kan, if you already try, you already success. Dah berjaya satu step. Okay, mengatasi rasa malas buat latihan kan. Okay, so salah ke? Tak ada masalah because you can always learn from the mistake that you make. Alright, so diagram shows, question number 4, tsunami originating from deep sea. Okay, so this is the deep sea. Okay, displacement here. So here tsunami start. And then it is observed that the distance between two adjacent, adjacent wave far apart at deep sea. Okay, adjacent wave, adjacent crest. And then as the wave move towards the beach, so the distance between two adjacent crest become closer. Okay, become closer. So write your inference, hypothesis. Then they give you this ripple tank, glass block. Okay, so you need to plan your experiment macam tadi. Alright, so type your manipulated responding constant variable. Terus tulis. Okay, type in your chat box. Okay, terus type 3, manipulated responding constant variable. Okay, ada jawapan lain? Manipulated depth of liquid, responding wavelength, constant variable, density of liquid. Okay, lagi? Vincent, manipulated depth, responding wavelength, constant frequency of wave. Okay, ada jawapan yang berbeza. Okay, we discuss. Tunggu lagi. If you have the same answer, you can copy paste so that I know you are responding. Wakil Sakura, wakil dari Sakura, can type your answer. CV can be speed of wave. Okay, we discuss. Tunggu sekejap, tunggu jawapan lain. Okay, let you think first. Distance between two adjacent wave. So it means this one is actually crest, far at deep sea, and then move towards the beach, distance become closer. So they refer to this. They refer actually to the distance between two crests here. Katakan here lah, cikgu ambil this point and this point. Okay, and then another one is here. Okay, and then this is the difference. And then here. Katakan cikgu ambil here lah. Okay, so far ada 3 jawapan. Alright, so the manipulated variable, yes, it is the depth of water. Okay, depth of water, betul. Responding variable is the obvious. Sekejap, this one is the depth. Can use D, can use H. Okay, up to you. Boleh guna H, boleh guna D. Let's say I put here as H1. This is H2. And then here is, this is wavelength. what you can see is the wavelength lah. Lambda 2, this is lambda 1. So obvious lambda 2 is bigger than lambda 1, and then H1 is bigger than H2. Alright, so you don't see the speed, okay? You don't see the speed. Sebenarnya the speed changes. So this is actually from V sama dengan F lambda. Okay, so this is the formula that relate to this. This is actually refraction of water. Okay, so the one that change is the depth. So when the depth decreases, the speed actually decreases. Okay, alright, so when the speed decreases, so it means that lambda will decrease. Okay, so you don't see lambda. Actually, lambda can become your responding variable, but you don't see it here. So you only see, sorry, pointing to V. Alright, so V actually can become your responding variable, but you don't see V, you don't see the speed. Okay, what you see is lambda. Alright, so that's why we prefer to use lambda as the responding variable. But it is not wrong if you write about speed, but make sure you write in bracket lah, represented by the lambda. Okay, but better to use lambda because the diagram here obviously shows you lambda. Okay, wavelength. Okay, cikgu baca respond you all. So density, can density become the constant variable or not? Density of the liquid, can or not? Here, since okay, a more accurate method to determine your constant variable will be by relating the variable with formula. Okay, so since we are using this formula, obvious F will be a constant variable. Okay, so jawapan constant variable here no other than the frequency. Okay, so density we don't accept. Ada lagi jawapan lain? Okay, good. Vincent already respond to that speed. Oh, okay, betul-betul. Kejap, cikgu tengah baca. Okay, boleh Okay, so from here, what is your... Come, we look at the answer. Okay, inference, betul? Wavelength depends on the depth of the liquid. Betul kan? Okay, this is correct. Okay, you read the hypothesis. This is correct. Hypothesis? The greater the depth of liquid, the longer the wavelength. Can? Correct, Okay. To investigate relationship between depth of liquid and wavelength. Can. Okay. So once you write a correct hypothesis, yang seterusnya selalunya selamat. Okay. So manipulated variable responding, boleh bagi markah di situ? Yes. Okay. Constant variable pun dah betul kan? So constant variable not compulsory to write symbol, tapi cikgu suka lah if you write F, F. Okay, so this is 1 mark. Okay. Alright, the apparatus, look at the diagram. For this experiment, diagram is quite hard. Okay, so we will spend more time on discussing whether that diagram is function or not. Okay, now look at the diagram and then look at the apparatus here. Ada yang kurang kah? What is missing? Teacher, ripple tank very hard to draw. Can teacher summarize out which component should have in the ripple tank when we draw the diagram? Oh, this one memang I know. Kalau cikgu lah, if I see the question kan, one is using ripple tank and then the other one is easier to draw. Just like this paper, Pahang paper, I will choose question number 3. Sebab cikgu pun tak suka nak lukis ripple tank. Okay? Yeah, I know. Quite hard to draw. Cikgu lukis pun tak cantik. Okay, now check. Apa yang kurang? Ataupun we look at, okay, we need to look at this first before we look at the procedure. So we spend quite a lot of time discuss this because the diagram will affect your procedure. Cannot see the motor. Ada already ada lukis tapi tak jelas lah. Try to elak daripada ripple tank and trolley. Trolley still okay. Trolley still okay. Beam is floating. Beam is floating. Is it floating? Nampak in the water. Ya, diagram kan memang ada susah sikit, tak apa. Need stroboscope. Okay. So this student already label, ada tulis tapi diagram tak ada. It's good to draw, lukis stroboscope. Lukislah berapa celah pun. Okay, so you draw label stroboscope. Okay. Lamp not functioning. How do you know lamp not functioning, Won? Okay, come. So ripple tank, glass block, white paper, lamp, motor, AC power supply, stroboscope, protractor. Protractor. What is the use of protractor? Pencil, horizontal, vibrating beam, and ruler. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think lengkap. Semua ada. Yeah, so this one semua ada. Okay. So all of these are important. Contoh macam this experiment you imagine like this. So katakan, okay, you don't have the lamp. So experiment is not function. Maksudnya diagram important. Let's say you don't have motor. You also cannot get the responding variable. So it means that diagram akan salah. Faham? Yeah, you do like that. Okay. Katakan no water. Can you do the experiment? Cannot. Maksudnya you cannot get the responding variable. So it means that must be labeled and must be written in the list. Katakan the horizontal beam, vibrator beam ataupun plane vibrator not here. Can you get the responding variable? Cannot. So maksudnya this is important. Okay. That is how you can determine whether need to be labeled or written or not. Okay. No cable. Alright, now Von's comment is good. Lamp not functioning. Yes. So the lamp need to do like this. Okay, that symbol showing that the lamp is on. Okay, tunjukkan this one lah. Alright, tunjukkan this one to show that your the lamp is switched on. Then another missing in this diagram, if like this we don't give mark. One, because of the lamp is not labeled. Okay, it is switched on. Another one is there is no power supply. So if no power supply, all katakan semua lengkap, also you cannot conduct the experiment. Okay, so mesti tunjuk. It's either, okay, there are two ways. Satu cara will be, okay, mesti ada kabel lah. Alright, so you have your cable and then you write here 2 power supply. And then here also you must have wire, katakanlah at least 1 wire. Sebenarnya we need 2 wire kan. Okay. So you write like this. You can put arrow, tuliskan 2 power supply. Here also 2 power supply. That is one way. Another way will be to draw, tambahkan satu kotak. Ataupun in 2D also can lah. So label this as power supply. So sambung. Walaupun to the same power supply, tak apa. Okay, it is function. Clear? And then this one, okay, if you use one, katakan, because sometimes we have, katakan for interference kan, we use this spherical dipper, round dipper. So can you use this round dipper for this experiment? Can or not? Katakan you don't write, ataupun you write here horizontal vibrating beam, but then here you lukis like this. Can or not? So semua dah cantik, okay, but you draw this two, it is wrong because this is for interference. But let's say, okay, now, okay, if like this confirm salah, walaupun diagram dah lengkap. So these are the small mistake that can hilangkan your markah. Katakan one only, can or not? Like this can, because still can determine the wavelength. Okay, but better to use plan. Alright? Clear? So this part sangat penting. So any electric experiment, so make sure you label connected to the power supply. Sekurang-kurangnya you label to power supply. To power supply. Alright? Connected to power supply. Okay. Apparatus set up above. Okay, fill the ripple tank with water to a depth of 1 cm. Okay, so this one is the first mark. Okay, so your first manipulated variable value. Okay, alright. Ataupun you can just write experiment is started by using water with a depth of d equal 1 cm. Then switch on the power supply. Trace wavelength shown by on white paper using pencil. Trace wavelength. Then measure and record the length of wavelength lambda using ruler. Experiment repeated. Okay, comment. Repeated. So this one, mark number 3. Okay. Alright, any comment? Apa yang kurang? Okay, electric experiment, bagus. Ada tulis here, switch on power supply. Okay, so now, for this case, you have two apparatus that is using electric, which is the motor and also the lamp. So you need to write both. So the lamp and motor are switched on. Okay. This lamp and the motor must be switched on. Okay, tulis that. If katakan already label sambung, then you can write switch. Power supply is switched on. Understood? That is for 2. Okay, but it's better to write for both. The lamp and the motor is switched on. Okay, apa yang kurang? What is missing here? If let's say the procedure is like this, can we get lambda or not? Water mesti tulis lah, Tio. You must have water, otherwise cannot conduct the experiment. Now, what is missing? Something is missing. You need to mention about this. How to write that? Yeah, stroboscope mesti tulis. Okay, Chai Chang Hong. So you need to write that in the procedure. Alright, so the wave is observed by using a stroboscope. Ataupun stroboscope is used to freeze the wave. Okay, must have that in your sentence. That is in order to get your lambda. So make sure you write stroboscope. Okay, faham? Okay, stroboscope is used to freeze. Means that as if the wave is freeze through the stroboscope. Then only you can write the wavelength is measured using ruler and recorded. Then only this can be given mark number 3. Mark number 2. This one. But if you don't write about stroboscope here, although this is a correct sentence, so it means that we cannot get the responding variable. Okay, means that not function. Ingat ripple tank, make sure you have the stroboscope. And then make sure the stroboscope are in 3. Number 1 is here. In the list of apparatus material perlu ada. Diagram perlu lukis. And then in the procedure also must have stroboscope. Okay, then repeat. Okay, so here betul lah. Okay, this is correct. This is also correct. Okay, 3 things. Name, symbol, unit. Faham? Like that. Name, symbol, unit. Name, symbol, unit. Okay, boleh? Why, Vincent and Boon? Sleepy already kah? Oh, freeze. Okay. Faham? But now, look at the question again. Look at the question again. Look at the apparatus they give. Do you see this? Glass block. Any glass block here? Oh, here ada glass block. Okay. But here, depth of water. Alright. So sebenarnya, the wavelength need to be measured at the area of the glass block. If katakan the marking is strict, they want to see you write measure the wavelength at the glass block. Okay, if they are strict, they want that. They will want that. Okay, so the wavelength lambda at the glass block region, okay, is measured using meter rule and recorded. Okay, so there are a few ways here. Okay, satu cara you put the glass block represent the depth. Okay, boleh. Ataupun you just put the glass block. I see some of the answer just now, they just add in water. Tambahkan water. Also, function means that can be given mark. Okay. Come, we look at this answer. So this one no problem kan? This one dah betul dah. So this is correct. The lower the depth, the shorter the wavelength. Okay. Relationship between depth and the wavelength produced. Okay. Variable. Okay. Now see. So depth of water betul. And the wavelength betul. So like this is already 1 mark for the manipulated responding. And then frequency. Alright. So this is actually frequency of the wave lah. Okay. Now, already written here, represent by the thickness of glass block, mm. Here, bukan unit sebenarnya. We need to write symbol. Okay, yes, Vincent, good comment, yes. Bukan unit. Okay, it should be symbol lah. Katakan you use X ke, ataupun H ke, alright? So, symbol, bukan unit. Unit, no need to write here. Okay, apparatus, ripple tank. This one we discussed already. What you should have. Okay. Look at this. So this one, I don't know whether lukis ke ataupun copy paste. Glass plate, glass block, ripple bar. ripple tank. So this one cikgu rasa no lah, huh? Macam pelik this one. Okay. So this one macam, I don't know. Nice drawing. Yeah. This student can draw very well. Faham eh? So if like this, you know what is the weakness kan? Okay, we discussed already. But I'm interested to see how the thickness of the glass block is used to represent the depth of the water. Come, we look at that. So, apparatus set up. So, fill ripple tank with water until depth of water is uniform. Okay, immerse the glass block with thickness 5 mm fully into the center of the ripple tank. Then switch on the motor to create vibration on surface of the water. Okay, kejap. So, not only the motor but also switch on the lamp. Mesti ada. Okay, so lamp. So, this one mesti ada switch on the lamp. Otherwise, your mark number 2 cannot be given. Just like this, mark number 2 cannot be given. Walaupun ada stroboscope. Then, okay, so if let's say this student already write, the lamp is switched on and the motor is switched on. So here can be given mark number 2. Okay, so this one cikgu terima for mark number 1. But better to write symbol lah, thickness, katakan X equal. Because when you already write symbol here, then later for your table and for your graph, you can use the same symbol. Depth D. And then here, thickness. Kan? Nampak ke ada macam lompat-lompat. So here you have, up here you have depth, but represent by the thickness. And then in the procedure you have thickness. Thickness, there is no depth, ada awal. But then here thickness, then tiba-tiba your graph become depth. So there must be sequence-nya. The story must be smooth story. Maksudnya, when up here you already mentioned the depth is represented by the thickness of the glass block. Okay, so bawah here also thickness of the glass block. This one betul. So this one should be thickness of the glass block. Okay. Tapi kan nampak lagi. Okay, this. Then how do you determine the depth of the water? Not clear. Represent by the thickness. Is it the thicker the glass block, the deeper the water? So is it like that? So for, okay, I suggest like this. If you use the thickness of the glass block to represent the depth of the water, so it's better to draw the side view, pandangan sisi of the ripple tank. What I mean is side view. So this is your ripple tank. This is your glass block, alright? And then up here is your water, kan? So this is the depth. Can put H depth, and then this one as katakan T pun boleh lah. Okay. So depth of water. So you can write this depth of water, comma, use H, right? H is equal to, katakan here is X, right? H sama dengan X minus T, where X is the, okay, yeah, you can refer to the diagram lah. T is the thickness of the glass block. Faham? Clear? Ataupun just like what Vincent write, the thicker the glass block, the shallower the water. Boleh tulis in the procedure. Okay? Maksud cikgu is the thickness of the glass block represent the depth of the water. The thicker the glass block, the shallower the water. Tulis dekat procedure. Okay, then can be given mark. Alright. So far boleh faham Okay, now it's already 11:30. Tapi bilangan student bertambah lah. I see just now sikit, now dah jadi 45. So means that you all memang tidur lewat lah. Okay. Ada soalan lain? So next time we can start at 12. Sebab I see semakin lewat, semakin the hypothesis is near to midnight, the number of student increases. So means that we can have our class at 12. Okay, boleh faham Okay, ada soalan lain? Okay, ada soalan lain? Have any more question? Okay, jap. This one jawapan Vincent. Oh ya, transistor. Cikgu plan nak buat esok transistor class, but then cikgu perlu siapkan the PAJSK. Cikgu perlu key in data, so I need time. So that's why cikgu tak dapat buat transistor. Actually, my planning is for tomorrow. So the transistor we will have next Saturday, insyaAllah. Next Saturday, like this lah. Okay, 9:30. Okay. So next week cikgu akan lebih free lah. Okay, I need to finish my key in data first. Okay. Tak ada soalan lain lah? Alright, so if no more question, saya hanya get the big picture of LDR and thermistor. Still don't know. Okay, now, so before I explain about transistor, what about the diode semiconductor? Ada masalah ke with diode semiconductor? Because transistor basic principle actually come from diode semiconductor. Okay, if let's say diode semiconductor, you can determine how is forward bias and reverse bias. So transistor, I can explain transistor. Maksudnya before transistor class, okay, make sure you all read about diode semiconductor first. Okay, baca diode semiconductor. Okay. So as usual, next week kan, cikgu akan naikkan notice for live session, and I will add in the link to the question okay, dekat bawah. So you can download the question, try first. Okay. So cikgu plan macam when I explain about transistor, I will set also question for the structure and essay question so that we can discuss. Okay. Alright, so if no more questions, so I think that's all for tonight. Okay, so hopefully after this, when you see question for the liquid pressure and also stroboscope, okay, you can write a better planning experiment. Alright, so till then, so ajak kawan-kawan join sekali. Okay, so hopefully when your result come out, next year everybody happy. Okay, so hopefully everybody can get good result for this subject. Alright, so all the best. Yeah, stay safe. Alright, Assalamualaikum and good night. Sweet dream. Okay, bye bye. Oh, Sharon, Jennifer is here. Alright. Okay, bye bye. Apai Salui, where you come from? Anis Nazrin, where you come from? Sebab nama-nama cikgu tak biasa tengok. Wafa, okay, where you come from? Sekolah? Tan, Tan nak cikgu tahu, right? Yeah, thank you for joining. Okay. Oh, Anis. Okay. Yeah, thank you for joining. Okay, good. Okay, salam, Mak. Okay, alright. Cikgu off, huh? Alright. Okay. Bye-bye.